Hello friends, now we are going to discuss about the engineering measures. So generally the engineering measures are used to adapt the reduce the soil erosion when the slope greater than the 2%. Okay, and where the agricultural or your biological methods are fails to control the erosion. In this condition the engineering measures are used. So those are your contour bund, graded bund, trenches, terraces and other gully control structures are used to erosion control. And the major advantage of this engineering measures are: one is to conserve the soil moisture and reduce the erosion. Also it will break the your land slope. These are the major advantage of the engineering measures. The first one is the bund. Simple, as is shown in this picture, the bunds are simple embankment like structures constructed along the contour or across the land slope. So contour, you know, the simple the equal elevation joining the line which have equal elevation. So let us, this is your land slope in this direction and we are constructing small embankment or simple bund across your land slope or simple equal elevation with respect to your any base line. Okay, these are bunds are used where the slope 2 to 10% and the annual rainfall less than your 600 mm. So these are the major two conditions to construct a bund. This practice was first introduced in your Maharashtra, India. Okay, let us see the types of bunds. The different types of bunds are used in the practice. Okay, those are contour bund. The contour bunds are constructed exactly on contour. Side bunds. Side bunds are formed at the extreme end of your contour bunds running along your land slope. So let us see the picture here. Let us suppose I am assuming this is contour bund. Okay, having equal elevation, okay, constructed across your slope. And another bund, this is another contour bund here. Okay, another contour bund here. So now whatever bunds which have constructed along the slope, these bunds, this small bund, this is another bund, these bunds act as your side bund and these are the extreme end of this field, particular field, and these bunds are meeting your contour bunds. And the bunds which have constructed between two side bunds, that is called your simple lateral bund. These lateral bunds are constructed between two side bunds along the slope. Okay, this is the along the slope for preventing the concentration of the water. When the water moving in this way, and it will bunds maybe reduce or stop the water which are flowing downward. That is the preventing the concentration of water at one side. Also break the length of contour bund into convenient bits as we discussed just now. And supplemental bund. Supplemental bunds are constructed between two contour bunds. This is the contour bunds, and to limit the horizontal spacing by its maximum extent are your nomenclature as supplemental bund. And marginal bund. So marginal mean it name itself indicate that marginal mean extreme end, that like your act as your margin. Okay, that's your boundary. Suppose this is my field. Okay, this is my field, this is my margin means my boundary here. Okay, whatever the bunds has been constructed here, so on this we can go for the like the field roads, rivers may pass along this bund, along this my field. So this is called your simple marginal bend. Okay na? And other shoulder bund is used in your terraces system, bench terraces system. Okay, to hold the runoff over the top of terraces. Okay, this type of shoulder bund we will discuss in the detail in terraces. Now classification of your bunding system. So bunds are based on your rainfall condition and soil. They have classified two types. One is your contour bund, another is your graded bund. The contour bunds may be not used in your clay soil. Please remember, this is the most important bit asked in examination. These are again contour bunds are again narrow base and broad base. The graded bund again subclassified into narrow base and broad base. Okay, the function of narrow base and broad base in contour bunding, also in gradient bunding, both are same. We'll discuss in next slide. Okay, now one is a contour bunding. The contour bunds are constructed along the point of equal elevation or across your land slope. That is your known as your contour bund. The contour bunds are also called your level terraces. The terracing system will discuss in the subsequent units. This is your simple the contour bund. The main function of this contour bund is to store the water which have fall on this land. Okay, now there is no grade has been provided to pass the excess water. So maybe the overland flow means overflow maybe takes place. Otherwise, if small grade has been provided, suppose the field itself have a little bit slope in this direction, so the small amount of water may flow along your bund. Okay, now the graded bund, where the rainfall greater than your 700 mm. Okay, in this condition there is chance of high amount of runoff in this particular field. So these bunds may not sustain, and in this condition the bund may break and it causes the more erosion. In this condition, to avoid such problem, the bunds are constructed with some slope or grade is provided. These are known as your graded bunding. So the grade normally provided 0.2 to 0.4%, depends on your field condition and available rainfall condition and soil type and the local condition. The graded bund, also known as your channel terraces, and are used where the rainfall receives more than your 700 mm. So let us see. This is the picture shows the slope in this direction. So the water properly disposing in downward stream. So thus water has not crossing your bund. So there is no chances of your erosion or no cutting your bund. And here also be small grade has been provided to dispose the excess water. Okay, these are the pictures you can show you can see in this picture the all type of graded bund has been provided and the small channel has been constructed. So let us see how the graded bund may be constructed. Now, so this is, if proper graded bunds has been not constructed, or suppose this is our contour bunds, so in this condition higher rainfall may be received in the area, so the overland flow takes place. So this is here in this condition graded bunds are not suitable. So we need to provide the proper channel. So in this condition, this is my rectangular field. Okay, now I need to construct based on this elevation, based on the many benchmark, we decide which direction our slope has been created. So now this is your baseline and this is your simple flow channel. So I need to construct the grade in this way, in this direction. Okay, I need to mark the starting point to construct the baseline, and every 19-meter interval we need to create another point. Okay, and at this point the zero elevation has been created using simple your water tubes. So now here both are water level at 0. So in this condition now I will move from one point again every 10 meter. Based on your 10 meter, we need to provide the grade your 0.2. So here grade is 0.2 provided because that is nothing but your 2 centimeter. So the elevation has been 2 centimeter. So with this grade, the water may flow from this point to here. Okay, like so based on your bench line, you need to mark the all point required points, and after every see here our next point has been provided, that is a 2 centimeter drop. The 0.2% means 0.2% means that is your grade, that is a 2 centimeter drop. Suppose 0.4% means 4 centimeter drop, 0.3% means 3 centimeter drop. Similar likewise we need to provide the grade throughout this length. Okay, again you need to change the point based on every 10-meter interval. So like here 10 meters, 10 meter, and here 4 meters. So in this condition, if the field is your length is shorter in this condition, so that is your 4 meter. So in this condition, for every 10 meter you are providing grade 2 centimeter. Okay, now that is 4 meter. How much? 1 centimeter. Suppose your distance is 7 meter. Okay, now in this condition, not either 10 meter or 9 meter or above. So in this condition, we need to provide 2 centimeter grade. Likewise, you need to provide the grade. That is a drop from here. Suppose my point 1, 2, 3, 4. So here 2 centimeter, 2 centimeter, and 1 centimeter. Total grade is, elevation is here 2 plus 2, 4 plus 1, 5. 5 centimeter drop has been provided. And I need to mark the, so here they marked the one elevation along your, which we have provided the grade. Earth is excavated, will need to form the your simple bund, and that is kept on your upper side of elevation. Kept on your upper side of elevation, that is your simple, this is your making the graded bund. Okay, and this is the another method, simple by your bund farmer. Okay, a ridge type bund farmer. With this also we can make the bund. So this is the how the graded bund may be constructed in your particular region. So now narrow base bund or broad base bund. Here the narrow base bunds mean these bunds are very narrow in shape and they create obstruction to pass your farm implements. Okay, whereas the broad bund, along this broad bund, the farm implement easily pass. Okay, cultivable area loss due to the small narrow bund. Okay, now either area can be available for your cultivation. Okay, now the bund section is liable for get affected by the erosion due to the rain, and this means here the bund very small, so the higher rainfall may be occurred in this particular region, so the bund may be get eroded. But in this broad base, that not has been happened. And next one is your contour trenches. Contour trenches are similar to your bunding, but in this system, the several trenches are excavated along the contours in a uniform level across your land slope at the top portion of the field. But the excavated earth material are placed at downstream. So whatever the material has been excavated, it is kept in downside of your trench and make the bund like structures. Similarly, it will also form your bund like structure. This is in inverted trapezoidal shape. The function of the contour trenches is to break the runoff velocity and intercept the runoff. So these are the where higher rainfall regions are there, that in that location these are constructed. Now the contour trenches may be continuous or interrupted. So you can see this is the continuous, okay, no, and interrupted. This is the interrupted, mean small gap has been provided in between these two trenches. Okay, now the interrupted trenches may constructed in the series in a staggered manner. So we can also call the interrupted, or these are the interrupted. Okay, the small gap has been provided in these bunds. Okay, that's called your interrupted or staggered trenches, and these are the continuous trenches. Okay, that is your graded trenches or continuous trenches, and next one is your staggered trenches. So now this is the example for your trenches are constructed where the high rainfall receives in your particular region. The staggered or interrupted trenches are here. See, this is the large gap has been provided between your trenches, and these are, see, so now this is the one row, this is the complete one row, and another row has provided a gap, means these two rays are not exactly, not below or not parallel, so some gap has been provided. That are the staggered trenches are constructed for a shorter length. See here, the shorter length has been constructed compared to a graded trenches. These trenches are arranged in the staggered form, means not in straight line. Suppose this is the one row and another maybe start from here. Here another trench, or here another trench, here another trench. In the row along the contour with interspace between them. Okay, now the staggered in sequence and alternate rows of the trenches are located directly below the another. So here means these are located one below another. So in particularly here the gap. Okay, now next row will collect the water. Another next row is gap has been provided. Similarly, this is the way. So mean the water may flow like this. Like this. Okay, here water collected. Again, the excess water may flow in this way. Mean these are the shape. So excess water may flow in this trench, and this water, again this water may flow in this way.